The last day of the mean value theorem, I have two problems that we're going to run through. This first one says a company introduces a product for which the number of units sold, S, is given by that equation where T is the time in months. Let's just do part A and then we'll worry about part B in a minute. It says find the average value of S of T during the first year. Well, average value we know is defined as the change of S over the change in T. So I'll go ahead and write that change of S over change in T. What's the change of S over the first year? Well, it'd be S of 12. So 12 being the number of months minus S of 0 all over 12 minus 0. Now what you're going to do is you're going to plug 12 in for there. And you're going to want to use a graphing calculator or some sort of calculator to compute this for you. But you'd have 200 times, let's see, 5 minus 9 over 14 because 2 plus 12 is 14. And then we have minus 200. And then we have 5 minus 9 halves. All over 12. I've used the calculator to compute this and it comes out to be 450 all over 7. So that's part A. During what month does S of T, S prime of T, equal the average value? Well, that means we've got to find that first derivative. So the first derivative would be, let's go ahead, keep our constant, 200. Okay, just like we always do. And then I'm going to go ahead and rewrite this off to the side. So this would really say 5 minus, this would be 9, and then 2 plus t to the negative first. So the derivative of 5 is 0. So I'll just bring this negative 1 out front, and I'll end up getting a positive 9. Rewrite what's on the inside, so 2 plus t, and then I'll lower that by 1, which gives me negative 2. So S prime of t is equal to 200 over 9 times 2 plus t squared. They want to know where S prime of t equals the average value. So where are these two equal to each other? So I'm going to go ahead and set those two equal to each other. I'll take 450 over 7 equal to 200. Oh, and I didn't write this one right. I just realized that back here. I need to go back and make a correction. This 9 should not be on the bottom. This 9 should really be on the top. I apologize for that. So where does this equal? The 200 and then 9 over 2 plus t squared. So what I end up getting and what I'm going to do is I'm going to move that. This really becomes 1800 over to the other side. So I'll divide by 1800 on both sides, which gives me 1 over 28. And then I have 1 over 2t squared. You can check me on that, but I'm really just dividing by 1800 on both sides, and I'll kind of write that gently in here. To finish this up, I will cross multiply, and I'll get 2 plus t squared equals 28. Square root both sides. 2 plus t equals the square root of, or plus or minus the square root of 28. And then I'll move the 2 over, so I have negative 2 plus or minus the square root of 28. Now only one of those is going to be the solution because negative minus a negative is going to give me negative times, so I don't want that one. The only one that's my solution is negative 2 plus square root of 28. And I will tell you that that's approximately 3.292. So during the third month, okay, or halfway through, or partially through the third month is when the derivative equals that average value. The last problem for this section is talking about an object being removed from a furnace and placed in an environment with a constant temperature of 90 degrees. It says its core temperature is 1500, but 5 hours later the core temperature is 390. Explain why there must exist a time in the interval where the temperature is decreasing at a rate of negative 222 Fahrenheit per hour. So what that's talking about when it's talking about rate is its derivative. We're going to use mean value theorem to help us do that. So mean value theorem says we can find the slope of that secant line. So what I'm going to first start out by doing is saying I'm going to let t sub 0, or t sub 0, equal 1500. At time 0, it is 1500. But 5 hours later, so t of 5 is 390. What I'm going to do is I'm going to find the slope of that secant line. So the slope of the secant line would be t of 5 minus t of 0 all over 5 minus 0. T of 5 is 390, the temperature after 5 hours. And T of 0 is the temperature it started out being, 1500, all over 5. Now 390 minus 1500, 390 minus 1500 is 1100, negative 1110. And that divided by 5 happens to be negative 222. So, by mean value theorem, there exists a time between 0 and 5 such that the derivative of that value, we'll call it C. I should probably rewrite this. There exists a time C between 5 and 0 such that the derivative of C equals negative 222. And that's because the slope of the secant line is negative 222. So that at some point along that curve, there also is a slope of the tangent line that is exactly the same.